Alright, and now let's get into problem number 4. It says a 65 kilogram crate is being accelerated at 7 meters per second squared up an incline, making a 25-degree angle with the horizontal. If the coefficient of the sliding friction between the crate and the incline is 0.2, how much force is required? Okay, so we have this crate. A crate is accelerated up an incline. If the coefficient of sliding friction between the crate is this, how much force is required? Okay, so it looks like that we're using a force to actually accelerate the crate up the incline. Okay, so now that we're starting off with this, let's draw in all of our forces. Okay, so we're moving up the incline, right? And it sounds like that, once again, we're using a force in order to actually get it up the incline. So where would you think that force is going to be? Hey, you know what? We're going to be applying a force in this direction, right? It could be a push or a pull. It doesn't really indicate whether or not that's the case. And then, are there any other forces acting on this object? We're going to have a frictional force, right? Is it kinetic or static? Okay, and once again, we do know that the object is moving in this direction over here. So therefore, I'm going to say that that's the positive direction. And also, we're going to indicate that this over here is also our positive direction. Now, let's draw out our two component vectors for our force due to gravity. And that's the rest of our free body diagram. I believe that we're done here. Alright, now let's pull out all the given information. What is this 65 kilograms telling us? And what is that 7 meters per second squared telling us? In which direction? And what about that 0.2? It says if the coefficient of sliding friction between the crate and the incline is 0.2. Okay, so that's our mu k. And what are we trying to find here? How much force is required? Alright, and I believe that we have all of our given information. Oh, you know what? One thing that I forgot over here is this. There we go. Alright, and let's draw out let's write out our two force equations. And let's say that all the forces acting upwards in this direction are positive. So therefore, we're going to be laying down our pencil, coming over here to our free body diagram. Let's scan. Ooh, there we go. We got our normal force. Are there any other forces acting in this direction? Let's scan. No, but we do have acting in the opposite direction, our FGY. Are there any other forces? Let's scan with our pencil. Nope, and that looks to be about it, right? Okay. And once again, is our object moving up or down in this direction whatsoever? No, it's moving in this direction. It's going up the incline. So therefore, the acceleration in that direction is going to equal 0, and 0 times any number is equal to 0. Okay, and what about all the forces acting in the x direction? We're going to lay down our pencil and once again do our scans. Okay, so we're scanning, and we see, hey, you know what? We have our applied force. Let's continue. So we have our scan. Oh, look at that, our kinetic friction. And that's going in the opposite direction. And let's do our scan again, make sure that we're not missing anything. And look at that. We have a third one, which is our FGX. And that's equal to our mass times acceleration. Is our object accelerating? Yes. So therefore, I know that I didn't create enough room for myself over here, but this is going to be equal to mass times acceleration. I'm just going to... Okay, and that's the setup for this problem.